and we are back, and we are going to do our question 3, to be thin or not thin. So, cylindrical system, radius here, length here, thickness here. Material is the orange curve here. So, we need to see, right at the full stress and strain tensors, the calculus values to the point where the orange curve begins to fail. So it will fail, and you can kind of choose kind of either or here. You can pick the stress at failure here, but I'm going to pick it right here. It's about 900 MPa. And that's going to be equal to our hoop stress. So if it's thin-walled. So first we have to see coordinate system, good. We know what our material is, ceramic. So Young's modulus is equal to 300 gigapascal. Our nu is equal to 0.2. And now we have to figure out our radius and all that good stuff. So I'm going to exit out of this. Sure. I'm going to quit our car. Actually, looks like we're all quit. So our radius is equal to 17 millimeters. A length, which doesn't matter, thickness of 0.7 millimeters. Young's modulus is equal to 300. I'm actually going to quit the kernel just to be safe. And we said, what was our... So first let's see if we're a hoop. So let me go ahead and just do that calculation real quick. Nu of 0.2. So let's do this. Good. Yeah, so we are thin-walled, so we know that in this dimension, the one direction is the hoop, two directions longitudinal. Strain will be essentially the same thing here. No temperatures changing, so hoop longitudinal. Everything else is 0. So we are in principal stress state. We are in plane stress, and it's the 1-2 plane. And we know that our sig H at failure is about 900 megapascal. Yes. So our sig H fail equals 950 times 10 to the 6. So I'm also going to define that my sig H is this, EH, EL. So we've got all of our definitions here. So we need to solve when does sig H fail equals sig H. Because that's what we essentially have. So that's our del P. Once we have our del P, we're asked, let's see, the full stress and strain tensors. So I got sig H, sig L, EH, EL. The strain gauge, the one is measuring my strain in the hoop. So that should be this value here. So that's B. I claim the material will yield via the Tresca criteria. So I know that my sig 1 is equal to sig H. My sig 2 is equal to sig L, and my sig 3 is equal to 0. So if I'm doing failure via the Tresca, I'm just saying that is sig 1 minus sig 3. Is it greater than, because my Rankine will just be that, Tresca and von Mises. My yield strength, I'm going to say it's about, let's say 300 megapascal. So 300 times 10 to the 6. It is, so it will indeed yield. Is the analysis valid? So it will yield. Tresca is typically for metals and polymers, things that are going to fail in maximum shear stress states. So a ceramic, I would probably use either von Mises or I would use Rankine. So I don't think the analysis is valid, actually. Is the fracture on the diagram correct? Yep, because we're pulling more here and here. Sigma hoop is always larger than sigma L, so that is indeed true. I have an initial crack size of this, surface tension of this, strain energy of this. Will this material crack? I'm going to use, this equation. So I'm going to use our expression that our stress at failure, or the stress applied, or basically stress is equal to square root of 2 gamma E over pi A, because we are a ceramic material. It is very brittle, so we should be able to use our Griffith criteria. The other one is our OR1 criteria for basically polymers and metals. So let's go ahead and say gamma equals 34. We already have Y. A naught is equal to 0.23 times 10 to the minus 3. And we know what the largest stress is going to be, and I'm going to assume that that's going to be our hoop. So I'm going to solve sig h equals, or actually we can just compare. So actually we're just going to do, let's go ahead and say square root of 2 times gamma. This is 2 times gamma times y divided by pi times a naught. So that stress is G stress, Griffith stress. So is our sig h greater than G stress? It is, so we are definitely going to fracture. And that's it. So see you all in the next problem. Thanks. Bye.